Hi, good afternoon. Good afternoon. Irene, can you hear my? All right, thank you. Okay, so today we will have our third tutorial. This is our final class actually. All right, our third tutorial for renewable energy. Okay, I will share the recording link later in a WhatsApp group. And as for today, we will cover on these types of renewable energy. Okay. Previously in our tutorial one, we have discussed on the introductions to renewable energy. Basically, we focus on the what is clean and green energy. I hope that you guys still remember. This one is just some revision what we have learned in tutorial one. Okay, on the introduction to renewable energy. We have discussed on the clean and green energy and some of the resources. And also we have discussed on the sustainability for the renewable energy. Okay, in unit 2, we have discussed on the fossil fuels and what are the resources for the fossil fuels. We have discussed on the coal. Okay, for the coal, we have the surface and deep mining. We also have the oil extracted by the from land and also from the sea, and same goes with the gas. Okay, for the uh, operations and the constructions of the plant for all these fossil fuel resources. All right. And as for today, we will discuss on the types of renewable energy. We have solar, wind energy, biomass, and the biofuels, the hydropower and geothermal, and also on the nanotechnology for renewable energy. That one is will be the final part for the unit 3. Okay, let's get started. Okay, this one is on unit 1. Okay, fuels can be easily made or renewed. We have discussed on this. We never use up renewable energy types of the renewable fuels. We have the hydropower or the from the water, solar from sun, wind, geothermal, and the biomass. There is also the sources such as from ocean energy for the bioenergy, and solar energy is among all that, solar energy is the most abundant of all energy resources. Okay, solar can even harness in a cloudy weather. And solar power or energy is pollution free and causes no greenhouse gases to be emitted after installations. And this is actually comes from the sun's ray or the solar radiations that reach on the earth's surface. Can be used for heating water and also heat spaces such as at our homes and also in the buildings. And we have the photovoltaic or the PV devices. This is we also sometimes call as the solar cells. It change the sunlight directly into electricity. Okay, for these PV devices, normally we can install at the residency homes, individual usage. Okay, and for the solar power plant, indirectly generates electricity when heat from solar thermal collector is used to heat a fluid, which produces steam that is used to power a generator. And there is actually advantages and disadvantages from the solar energy, such as for the advantages, we can reduce electricity bills also for diverse applications. And we also need low maintenance costs. And this is also good for technology development. Okay, but then from the advantages, we also have the disadvantages for this solar energy. This solar can be harnessed depends on the weather, and this is we call it as the weather dependent. And solar energy storage is slightly more expensive at the early stage for the installations, And also the solar uses a lot of spaces. That is why when we have a solar plant, it needs a very large or wide area. Okay. For solar photovoltaic devices or the solar cells, it can change the sunlight directly into electricity, and we have two main benefits over the solar energy. As we know that the system do not produce any pollutants or carbon dioxide that may be harmful to living things, to humans or to plants or animals. And the systems on buildings have a minimal impact on the environment, such as that we put at the rooftop over the buildings. And we have also the limitations of the solar energy. Okay, because that one is the solar is depend on the weather, the amount of sunlight that arrives the Earth's surface is not constant. Okay, depending on the locations, time and time of the day, seasons, and weather conditions. It is subject to temporary weather disruptions. Okay, and the amount of sunlight reaching a square foot of the Earth's surface is relatively small. So a large surface area is necessary to absorb or to collect all the useful amount of energy. That is why for the solar plant normally needs a lot of spaces or large area. Okay, let's see some figures. Okay, this is types of solar power. Okay, we have the first one is on the PV devices or the photovoltaic devices. And the second is on the solar power. The third one is the solar power plant. And final one is the solar power tower. Okay, for the usage for individual, the one that the residency normally put at their rooftop is the PV devices. And the one that we can see in a rural area for solar power plant need a very large area. Okay, for solar power works by converting energy from the sun into power. There are two forms of energy generated from the sun for our use. It can be in terms of the electricity and also in terms of for the heat. Okay, both are generated through the use of solar panels, which range in size of residential rooftop to solar farms stretching over acres of the rural lands, such as if we have, for example, here solar power plants. Okay, next one we go for the wind energy. Okay, for wind energy, air in motion caused by uneven heating of the Earth's surface by the sun. As you guys can see here, we have the wind turbine. Okay, we have blades, rotor, and the generator controller, and also on the tower beam. Okay, need large atmospheric winds that circle the Earth are created because of the land near the Earth's equator is heated more than the sun than the land near the north and poles, source poles. Okay, for the wind power and energy describes the process by which the wind is used to generate mechanical power or the electricity. And the wind turbine convert the kinetic energy in the wind into mechanical power. As you guys can see here, we have the blades. So the movements of blades, they can convert into the kinetic energy. Okay, from the energy, we can get the electricity, all right, and power. Okay, for the wind energy, also we have the advantages and disadvantages. Okay, for the good side of the wind energy, it is clean and renewable sources of power. We have the wind flow or over the time and cost effective, rapid growth of industry for large potentials, and the wind is consistent in the medium and also for the long term. However, for the disadvantageous part, okay, it is really depend on the wind reliability. And this one we consider also threat to wildlife because for the blades, might be harmful to some animals. Okay, white plant can impact local, the wing plant can impact local wildlife. Okay, and the movements of the blades also can produce noise and visual pollution. Okay, because the turbines produce noise during the movements. And the ideal wind sites often in the remote locations in the rural area. As you guys can see here, we have a large uh, wind site. And some people might say that this one is visual pollution. Okay. So next one we have on the biomass and biofuels. Okay. This one is just revisions. What is the biomass and biofuels? They refer to organic matter derived from plants and animals that plants and animals use as a source of energy, can include things like wood, crops, and even food waste. And the biofuels, fuels that are produced from the biomass typically used as a renewable alternative to fossil fuels. And for example of that is we have the ethanol and the biodiesel. And biomass is the only renewable energy source that can be converted into liquid biofuels, such as for the ethanol and biodiesel. And biofuels is used to power our vehicles for everyday use, and is being produced by gasifications in countries such as for large countries such as in Sweden, Austria, and in the US. Okay, and biofuels, fuels that made from the biomass material. But then the biofuels do not burn as much as the fossil fuel. And we can say that it is not as efficient as fossil fuels. Okay, and biofuels are we consider as cleaner burning and produce fewer air pollutions as compared to the fossil fuels. Biomass is typically solid and biofuels are often liquid or in terms of gases and represents more defined source of the bioenergy. Okay, we have two common types of biofuels. Okay, one is the ethanol and the second one is on the biodiesel. Okay, ethanol yields around 24% more energy than the energy invested in its productions, whereas for biodiesel, it's a very high energy percentage, around 93% more than the ethanol. To make the biomass into liquid or gaseous fuels, biofuels must be converted from the original form. From their original form, the most basic way to do is through fermentations of crops that are high in sugar or the starch in fat into ethanol, which can be mixed directly into gasoline to power cars, for example. Okay, so here we have the circle for the biofuels. Okay, from the usage, the ethanol, we can say it is an alcohol and mostly used as a fuels additive to cut down a vehicle carbon monoxide and other smoke causing emissions, as you guys can see here. Okay, how to get the biofuels from the solar energy and then from the crops, okay, from the sugar or starch, and from the process we can get on the biofuels. And biofuels is made by combining alcohol, usually methanol, with vegetable oil, animal fat, or recycled cooking grease. And it can be used as additions to reduce vehicle emissions around 20% in the pure forms as the renewable alternative fuels or the for the diesel engine. And methanol is particularly preferred because of its physical and chemical advantages. Okay, methanol and ethanol are most often used alcohols in biodiesel productions, okay, due to the chemical advantages. Okay, this is advantages and disadvantages that we have for biofuels. Okay, the good side is easy to source, easy to get on the raw sources, and meaning that it is reliability high. Okay, and this one we can also consider as renewable and reduce the greenhouse gases, okay, from the gas reductions and reduce dependence on the foreign energy. But then for the disadvantages, we need a higher cost of productions and because lower supply than gasoline, and from the monoculture activations of single crops at a time, okay, for industrial pollutions, and it can be some shortage of food, and on terms of the water use, some adverse environmental impact. Okay, for example, as you guys can see this figure here, these crops are grown for biofuel purpose. Okay, next one we go for hydropower energy. Okay, hydropower or hydroelectric power is one of the oldest and largest sources of renewable energy, which uses the natural flow of moving to generate electricity. And hydropower is a form of renewable energy generated by harnessing the kinetic energy of falling water in hydropower plant. Okay, due to movements of the water can get the kinetic energy, and then we can produce the electricity from that. Okay, this energy is typically converted into electricity by using the turbine and generators. The hydropower is clean. We consider this one is pollution-free and reliable source of energy that do not produce greenhouse gas emissions or other pollutions. Okay, this one is less expensive than traditional fossil fuels-based energy sources in widely used around the world. But then this one also need a very large area. Okay. This is the hydrologic cycle. We also call as the water cycle. Okay, this as you guys can see here, this one is the continuous movements of water on and above, also on below the surface of the earth. Okay, this hydrologic cycle involves the continuous circulations of water in the earth atmosphere system. Okay, at this core, the water cycle is the motions of the water from the ground to the atmosphere, and then it can be returned back to the ocean and the land as well. Okay, this is how the hydropower works. Okay, throttle from the reservoir flow due to the gravity to drive on the turbine, and then the turbine, here the turbine. Okay, we can connect with the generator, and from the generator we can get on the electricity that connect over the power lines. Okay, at the plant level, the water flows through a pipe also known as penstock, and then the penstock will spin a blade in a turbine, which is turn the spins a generator that ultimately produce electricity. Most conventional hydroelectric facilities operate these ways, including run of the river system and also at the pump storage system. Okay, next we go for the geothermal energy. Geothermal, it is comes from the word geo, or geo is for earth and thermal is for the heat. And we have the geothermal energy comes from heat produced by the earth. Okay, the heat from the earth uses the steam and hot water produced inside the earth to heat buildings or generate electricity. And we consider this geothermal energy as a renewable energy source because the water is replenished by rainfall and the heat is continuously produced inside the earth over the time. Okay. Its source, the naturally heat generated and stored deep inside the earth. And the heat can be captured and used directly for heat, or their steam can be used to generate electricity. For example, we have the magma from volcanoes heats nearby rocks and underground aquifers. Hot water can be released through geysers, hot spring, and also on the steam vents and from the mud pots. Okay, next we have on the geothermal energy. Okay, as you guys can see, this one is on the figure here is on the earth interior. We have on the crust, the earth surface up until on the iron core. So the heat is actually produced from the center of the earth. Okay, we can say from the iron core. The direct geothermal energy can be accessed in areas where hot springs or geothermal reservoirs are near the surface of the earth. The thermal energy is stored in rocks and fluids in the center of the earth. And geothermal energy is heat energy from the earth. We have the from word geo, earth, and also thermal for the heat. And geothermal resources are reservoirs of hot water that exist or from human-made varying temperature and depth below the Earth's surface. Before here, we have the geothermal heat pumps utilizes a series of underground pipes, an electric compressor, and a heat exchanger to absorb and transfer heat. The geothermal power plants also harness the heat of the earth through hot water and steam. In this plant, heat is used to generate electricity as the sources. Okay, so this is the locations for the geothermal energy. Remember, not all area or not all surface on the earth have the geothermal energy. Okay, the most active geothermal resources are usually found along major tectonic plate boundaries where most volcanoes are located. So for here, the red dotted is on the locations for the volcanoes. Okay, we call it as the ring of fire. One of the most active geothermal area in the world is called Ring of Fire, which encircles the Pacific Oceans. And the Ring of Fire lines the edges of the Pacific Oceans. Around the country includes Australia and some countries in Asia, or also goes to North America and South America along the Pacific Ocean. Okay, next is on the geothermal plants and heat pumps. The geothermal power plants generate electricity by forcing hot steam or hot steam from the earth interior through a turbine. Okay, and the hydrothermal fluids above, for example, around 170 degrees can be used in flash plants to make electricity. The direct drive steam, the dry steam plants use hydrothermal fluids. Okay, we call it as the primary steam. Okay, we have the three types of geothermal plants: dry steam plant, flash steam plants, and also the binary power plant. Okay, for the binary power plants, most geothermal areas contains moderate temperature water, let's say around below 200 degrees Celsius. And the geothermal heat pumps are the most energy efficient, environmental clean, pollution free, and cost effective system for temperature control. Okay, we have advantages and disadvantages as well from this geothermal energy. Okay, the advantages, it is always renewable energy and reliable and available. Okay, and this one also cleaner than burning fossil fuels, can reduce energy consumption and corresponding emission, pollution free. But then for the disadvantages, cost of drilling, because we need to get the heat trapped from the earth center. Okay, And high cost, researching proper area to find new sources can also require a suitable locations. Location restricted, the largest single disadvantages of geothermal energy is that it is location specific. Okay, as we saw just now, okay, at the ring of fire location. Okay, so next one we go for nanotechnology for renewable energy. Nanotechnology is the tool that can make possible the production of hydrogen from solar energy in a clean, environmental friendly, and also for low cost. Okay, before we start, let's find out the definition. What is actually under nanotechnology? Okay, as many definitions for the nanotechnology, the NNI or the National Nanotechnology Initiative, NNI calls the nanotechnology only for if involved and have this specific criteria here. We have three criteria. Okay, they list down the three criteria: research and technology development at the atomic, molecular, or micromolecular levels in the length scale of approximate 1 to 100 nanometer ranges only. And creating and using structures, devices, and systems that have novel properties and functions. Okay, because that one is very small or in terms of the intermediate size of the atoms or the structures. Okay, and the third one is ability to control or manipulate on the atomic scale, in the very small scale area. Okay, this is for nanoscience and solar energy. Okay, nanotechnology could boost the solar energy efficiently, and also we can cut the original cost. The silicon nanoparticles enhance solar cells when applied for solar power products. And for the size and microstructure of silicon nanoparticles, as well as the luminescence and quantum efficiency properties are highly specific. Okay, we have the manipulations of photons, electrons, and molecules here. For the quantum dot solar cells, the quantum dot solar cells is a solar cells design that uses quantum dots as the absorbing photovoltaic material in the PV for the solar energy harness. Okay, this one involves using a liquid process to put a billions of nanocrystals. Okay, we also have the artificial photosynthesis here, and also nanostructure thermoelectrics from the nanoscience energy. Okay, this one is on the characterizing nanomaterials. Okay, we have nanocapsule, ultrafine aerosol, quantum dots, nanochips, and the nanoparticles. A nanoparticulate material is a substance that consists of a nanoparticles. Okay, we have the origins, the chemical compositions, okay, from the metal oxides, polymer, carbon, semiconductors, biomolecules, and some other compounds. And on the aggregation state, for single particles, aggregates, and agglomerates. Also, this one is for nanoparticles suitable for the surface modifications, and also for the shapes of the structures, for the nanostructures, and also on the dispersions for gases, liquids, or either on the solids. Okay, so this one is actually a new area of the nanotechnology. Okay, we are at the beginning of a revolution for how things are made, okay, and where things are made, and also whether how or is it possible to be made. Okay, the time we're living now, we call it as the technology era. We have seen the effect of the agriculture era and the industrial revolutions. Now we are going through the technological revolutions. Like previous revolution, technology has affected on the living or life's living standard, and every aspects of the life is a greater way. Okay. So that one, it is on the technology also for humans, for animals. Okay. But we have the challenge. The use nanotechnology has already been embraced by industrial sector such as the informations and communication sectors, but it is also used in food technology, the energy technology, as well as in some medical products and medicine. Okay, help clean up past environmental damage from the nanotechnology is skills. Okay, we can correct present environmental problems. Also, we hope to prevent future environmental impact and help to sustain our Earth, our planet for future generations, for our kids. Okay, and the nanomaterials may also offer few opportunities for the reductions of environmental pollutions by all these four nanotechnology research. Okay. However, we have a challenge from the nanotechnology area. Okay, applications for measurements in the environment. Okay, for the vision, the unique properties of nanoscale materials will enable the development of a new generations of environmental sensing system. Okay, we can reduce on the environmental pollutions, but in addition, the measurement science and technology will enable the development of comprehensive understanding of the interactions and fate of natural and anthropogenic nanoscales. This one is under physical enhancement. Okay, for this number two, the applications for sustainable material and resources. Okay, we want to improve manufacturing methods for better, for example, for better food production method. Okay, develop uses and dissipates materials for the flow, recovery, and recyclable of renewable resources. Okay, and this one we have another three challenges here. Okay, for the applications for sustainable process, they were mainly on the energy system. For example, for the nutrition and large scale infrastructure auto fabrication. And for number four is on the implications in natural and global process for higher use of natural resources and also in terms of the water purification system. For the number five is the implications in human health and in environmental safety. In terms of the nanomedicines, we want to improve humans' health. Okay, development of nanotechnology responsible with the full appreciations of its health and environmental impacts. Okay, in terms of the nanomedicines for to improve the human health. Okay, so this is the final one. Okay, nanotechnology is an emerging field. We already knew that, and in which new and innovative tools are being developed to tackle issues that more important is on the water, air, and the soil pollution on the earth. Nanotechnology and nanoscience will have impact in energy use for the storage, conversions, and the sources. And the energy challenges are globally linked for social industrial needs, and innovations in nanotechnology will help solve future energy problems. It is agreed that the nanotechnology has significantly contributed in benefiting social life, society, and shaping the nature of next future generations for modern life. The nanotechnology can boost the economic growth as well as improve the capacity and quality in industrial sector. Okay, and it is assumed that it can significantly change the human life, social environment, and on the country's economy as well from the economic sector. Okay, so we have come towards the end of the tutorial 3. Alright, before we end, please write down your name for the attendance. Is